Hi, I'm Ian, and this is a technical introduction to field recording. In this episode, I'm going to talk about the different connection schemes that exist for connecting a microphone to a recorder. I don't want to get into the real techie aspects of field recording here, and ideally I wouldn't have to, and neither would you. But if you're setting up a field recording kit, there's one thing you need to be aware of, and that is the different schemes used to connect microphones to recorders. There are two major systems used, and they're generally called consumer and pro. Those are pretty rubbish terms, but they're also kind of descriptive, so I'll stick with them. So let's get into it. But first, let me talk about one potential pitfall: connector ambiguity. In an ideal world, the physical shape of a connector would be matched to its purpose. For example, you can't plug an HDMI video connector into a USB port because the connectors are physically different. And that's deliberate. The idea is that if it plugs, it works. It's not that simple in practice, but if it plugs, you're at least in with a chance. Unfortunately, most of the connectors we use in audio predate this idea, and a single style of connector could be used for different purposes, to the point where they're not electrically compatible and could even damage your gear if you connect them. For example, a recorder might use a 3.5mm TRS jack for a microphone input and also for the headphones output, but plug your mic into the headphones jack and it could be damaged. Similar things happen with XLR, which has been used for all kinds of things. So it's up to the user, you, to know what a connector is actually being used for and to check before you plug it. So plugger beware. Most field recording setups use analog connections, so let's start there. With an analog connection, your mic converts air pressure variations, i.e. sound, into a varying voltage. That voltage is then sent down the wire to the recorder, where it's amplified with a preamp and then digitized. This mic level signal is very low level, like millivolts, and hence prone to electrical interference or noise. Basically, your microphone cable acts as an aerial or an antenna and picks up any electrical noise around and adds it to the signal. This noise can be a real problem because it could easily be as loud as the signal you're trying to record. Headphone, speaker and line level signals are much higher level, and so they aren't affected in the same way. So the mic signal is very fragile, and how you get it to the recorder really matters. Unfortunately, there are two main systems for doing this and they aren't compatible. So we need to choose between them, or at least be aware of the issues. The consumer system uses the very common 3.5mm TRS jack. You'll see these on headphones and all kinds of other stuff. TRS stands for tip, ring, sleeve. The tip is the left channel signal, the ring is the right channel signal, and the sleeve is the reference ground. A mono connection might just have tip and sleeve. This kind of connection is called unbalanced because there's just one signal wire for each channel, plus the reference ground. It's very easy, but there's no real protection against interference except to keep the cables short, like a few feet or so. You should certainly use shielded cables, but they still need to be kept short. So the consumer system is pretty simplistic, but that doesn't mean it can't deliver. There are some good recorders and mics available in the consumer world, and they tend to be both cheap and portable. The Pro system, and it is the system that professionals mostly use, uses a different kind of connector, the XLR connector. This connector is really old and it's big and clunky, but it's also robust and it latches into the device. This can be really handy in the field. XLR uses 3 connecting pins for a single channel. These are the reference ground and the signal plus and minus. This is called a balanced system because the signal is transmitted on 2 wires which are the inverse of each other. The actual signal is the difference between those 2 wires. Any interference will add to both wires equally and won't affect the difference between the signals, so it's effectively cancelled out. The signal wires are often twisted together into what's called a twisted pair to make sure that any interference really does add to both the wires equally. This system still isn't perfect, but it gets you very good noise protection. It's quite possible to run cables up to 200 meters, 650 feet or more. Bear in mind that a 3-pin XLR connector only gets you one channel. For stereo, you'll want two of these or a 5-pin connector, but in that case you'll want a Y cable to connect it into your recorder. Top-of-the-line Audio Gear uses this XLR-based system, but there are also recorders and microphones available at affordable prices, so it doesn't have to break the bank. Condenser microphones generally need power, and if your microphone doesn't have a battery built into it, then it's going to need power supplied up the wire. In theory, this is pretty straightforward, but unfortunately the way the two systems do it in practice is completely different. In the consumer world, the system used is called plug-in power, and it usually runs on 3 or 5 volts. The system used in the pro world is called phantom power. It uses a totally different wiring scheme, and it generally runs on 48 volts, or 24, or sometimes 12, so it's not compatible. If you're looking at older used gear, watch out for different powering schemes that were used. For example, T-Power was an alternative to phantom power, but it's not compatible. You'll quite often see 1/4-inch TRS or tip ring sleeve jacks in audio gear, usually in the form of an XLR input that has a 1/4-inch jack combined with it. 1/4-inch plugs are sometimes used in audio, but how they're used is a bit ambiguous. They can be mic level or line level, balanced or unbalanced. If you do come across one of these, check what the deal is before plugging anything. For example, your recorder may support 1/4-inch plugs for mic level inputs or for line level inputs, or it may be switchable between those. So there are two connection systems, and compatibility between them is a problem. So is there an easy way around this? Well, there are simple plug adapters available, and these can work, and they sometimes do work, but they can also cause problems. For example, this could make a balanced connection work as an unbalanced connection, and you'll lose your protection against interference. Also remember that the powering schemes used in the consumer and pro worlds are totally incompatible. You might be able to connect a balanced microphone into an unbalanced input using a preamplifier, but that's another electronics box to carry around with its own batteries, and a good preamp might cost as much as a recorder. So if you're setting up a system for field recording, you might want to think about making a choice. Go for a consumer system that's small, cheap and very portable, or get a recorder with XLR inputs that will let you plug in just about any kind of microphone in the future. So that's analog connections, which, as I said before, are the majority of all mic connections used in field recording. But what about digital? The standard for digital audio is called AES-42. In this world, the microphone has an analog to digital converter built right into it, so the connection from the mic to the recorder is a data connection. It's just a stream of numbers. So there's really no worries about noise or interference on the wire. Mics can even be networked, for example, in setting up a concert hall. So AES-42 is great, so why not use it? Well, basically because nobody's using it. The system's pretty moribund, there's not much kit on the market, and what there is tends to be really pricey. I think basically it solves a problem that most audio professionals felt they don't have. With balanced connections being so good at getting a clear signal to your recorder, there's really no pressure to go digital. There is another way to go digital, which is available to just about everybody, and that is USB. A USB microphone can be plugged into just about any computer and you're good to go. But for field recording, this doesn't work so well. It's basically good for computers only, since field recorders don't provide a USB host port. Also, USB is very limited on cable length. For these reasons, USB microphones tend to be studio-style microphones, not really applicable to the field. Still, it could be done in the field. For example, a Windows tablet might provide a true USB host port. If you're thinking about a phone with a USB adapter, watch out for powering issues, and of course you'll need software which can record from the USB. One interesting exception to the studio mic issue is the Ultra mic. This is an ultrasonic microphone which has a USB interface, so it can connect to any device with a USB host port. This can be useful in the field, for example for recording bats. So for most purposes in field recording, the connection from the mic to the recorder will be analog. It's just a shame that there are two basically incompatible systems to choose from. The choice between them isn't straightforward, and both can work well in field recording. A consumer system will be cheap and portable, but a pro system will give you a clear upgrade path with no limits. And with an analog connection, interference will always be an issue. The Pro system is the clear winner here, as its balanced connection scheme gives you great noise rejection.